So in this video, we are going to start Unit 2, and we're going to look at Section 5.1, the basic concepts of probability. So you need your Unit 2 packet to follow along with this video. So this is a very important concept. It's the basics of half of what we're doing in Unit 2, and so it's really important that you get this concept down, and if you're not sure about things, to come follow up and ask me. So we kind of have 4 objectives for this. We want to find the probability of a simple event, and we'll talk about what an event is. We want to write out the sample space of an event. We want to be able to find the probability from a sampling event, and we want to be able to determine if an event is unusual based on the probability. So when we talk about probability, the probability of an event is the proportion of times that event occurs in the long run. And we can often determine the probability by doing a probability experiment. And a probability experiment is one in which we don't know what any individual outcome will be, but we do know how a long series of repetitions will come out. So for example, if we toss a coin, we don't know what the outcome of a single toss will be. It could be a heads, it could be a tails, but we do know that if I keep flipping that coin, we should get about half heads and half tails because a coin is half a head and half a tail. Like there's one head and there's one tail and there's 2 outcomes. And so this idea is called the law of large numbers. If we do a probability experiment and it's repeated again and again, the proportion of times that a given event occur will approach the probability. Okay, and the proportion of times means like the number of times we get ahead out of the total number of flips that we do. So if we're finding the proportion of heads and we flip a head, the first head we get, it means the proportion is 1 because we got 1 head out of 1 toss. But as we keep flipping, we're going to get some heads, some tails, and it will be different every time we do this experiment. But as we get more and more flips, and in this experiment it was after 100, we are going to get closer and closer to getting half heads and half tails. And because we're getting half, that means that we're getting closer and closer to 50% heads, which is a proportion of 0.5. And that's the idea behind doing a probability experiment. So when we're doing probability, we're often interested in the sample space, and the sample space is a very useful tool for helping us figure out probability. So the sample space is the collection of all the possible outcomes of a probability experiment. And when we describe the sample space, we usually write the outcomes in curly brackets like this, and we put all the possible outcomes. So when we flip a coin, we think, okay, what is on a coin? We have 2 options. We could have a head or we could have a tail. And usually we just put H and T. If you want to write out heads and tails, you can, but H and T is good enough. So this is my sample space. If I want to roll a die, if I think about a die, and if you have a game and you want to get one out to look at, okay, on the die I have numbers 1 through 6. And so the sample space is writing all those possibilities that I could get. I could roll a 1, I could roll a 2, a 3, a 4, a 5, and a 6. And so this is the sample space. And there are 6 outcomes in my sample space. Okay? And when I toss a coin, there's 2 outcomes. The selection of a student at random from a list of 10,000 at a large university. So in this case, what we would do is we would give each student a number from 1 to 10,000, and our sample space would be all of those numbers. So my sample space would be student number 1, and then 2, and then 3, and then 4. And when we have a very large sample space, we do not write them all out because that would pretty much be impossible or take way too long. And so we put dot, 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 and we put the last option. And so my sample space would be the numbers from 1 to 10,000. Now we are going to be looking at finding the probability of different events. So in general, if A denotes an event, the probability of event A is denoted by the probability of A. Here. So please add this. I didn't have it in the packet, but it's probably good to add that an event is a collection of outcomes. So if I want the probability of a heads, my event would be getting a head. I could do the probability of rolling a 3, then my event would be rolling a 3. There's certain rules for probability, and it's really good to keep these in mind when you're doing probability, because it will, if you violate one of these rules, then you know you made a mistake when calculating the probability. So the probability event is always between 0 and 1. Okay, so in other words, for any event A, 1 is less than or equal to the probability of A, which is less than or equal to 1. Sorry, 0 is less than or equal to probability A, which is less than or equal to probability 1. Now, the only time that we have the probability equals 0 is if A cannot occur. So the probability of A equals 0 if it is impossible for A to occur. So if I said I'm rolling a die, a single die, what is the probability of rolling a 7? That probability would be 0 because it's impossible to get a 7 if I'm rolling a single die. If it is certain to occur, then the probability of that event is 1. There's 100% chance that it is going to occur. So how we find probabilities is we think about their sample space. And if a sample space has n equally likely outcomes, and an event A has k outcomes, then the probability of A is the number of ways to get A over the total number of outcomes. So in this case, we have k outcomes, so it would be k over n. So if I talk about what is the probability of getting a head, we know again that the sample space is heads, tails. And so the probability of getting a heads each flip is I have one head, there's one way of getting a head out of 2 total outcomes because there's 2 outcomes in our sample space. And so the probability of getting a head is 1/2. And we often talk about percentages and percentage is a probability. If there's a 60% chance of rain, that means the probability is 0.60 or 0.6. Or you can think of it as a fraction, 60 over 100. Okay, because again, a probability is really just a proportion is a fraction. So we're going to do a few examples. So I want to find the following probabilities if you roll a single die. So I want the probability of rolling a 2. So I know some of you can just look at it and tell me, but we're going to write out the sample space and think about it using that formula. So my sample space of rolling a die is the numbers 1 through 6. And if I want the probability of rolling a 2, we usually write the probability of 2 equals, it would be the number of ways to get a 2 over the total number of outcomes. So if I look at my sample space, I can say, okay, I have one way of getting a 2, and I have 1, 2, 3, 6 outcomes. So yeah, but 6 outcomes. And so the probability of getting a 2 is 1 out of 6. And usually we leave these probabilities as reduced fractions or decimals, but this decimal keeps going, so it's better to do a reduced fraction. B says find the probability of rolling an even number. Okay, so again, if I look at my sample space, I say, okay, I have even number 2, 4, and 6. So how many ways can I get an even number? is 3, again, over the total outcomes. Which is 6. Okay, and then we usually either reduce it 1/2, or you could say 0.5 in this case, because you don't have to round the decimal. So that's how we find kind of the basic probability. So let's look at another one. We flip a coin 2 times, and this one is helpful to write out the sample space. So we need to write out all of the options. So we have to think about, okay, what happens on each flip, and what are all the possibilities? So how we write this is we say, okay, what happens our first flip and our second flip? And we do that for each option. So I could get a tails and I could get another tails. Or I could get a tails first and then a heads. Or I could get a heads first and then a tails. Or I could get a head and a head. And then that covers all the possible outcomes. So this is my sample space. I'm sorry, I told me to write it out here. So they might not always tell you to write out the sample space, but it's often helpful even if they don't. So these are all my possible outcomes. And tails heads is different than heads tails. The order matters, so you need to write both. And then it says, what is the probability of flipping 2 tails? Okay, so the probability of tails tails is the number of ways that we get tails tails over the total number of outcomes. And that's the total in our sample space. So we get 1 out of 4. So that's the basics of probability, and we'll pick up a few more examples in the next video.